Alright, let's have situation 10. Given the following data of the bath connection showed. So, all of the dimensions is given. Okay? Then, allowable stresses. Here on bolt, 117 megapascal. Tension on net area of plate. Tension on gross area of plate. And bearing on plate. These are the allowable stresses. So, number 31, compute the minimum required bolt diameter based on bolt shear. If P is 320 kilonewtons. So, this is a steel design. But, kung iisipin natin, yung concept dito is just strength of materials. Simple stresses. Hindi na kailangan ng code kasi binigay na yung mga allowable stresses dito. Okay? So, strength of materials lang yung kailangan natin na concept. Compute the minimum required bolt diameter based on bolt shear. So, ano ba yung itsura ng bolt shear dito? So, kung titingnan natin yung isang side only, of course, hindi yan continuously connected, no? Separate yan. Tingnan natin dito. Pag-apply ng force P, this will be in double shear. Yan. Okay? So, matatanggal yung bolt na yan. So, we have a double shear failure. Alright. So, tingnan natin to dito. Ito yung ating shearing area. Of course, diameter ng bolt yung gagamitin natin. Then, these are the reaction. Yeah? Each of the bolt will carry P over 4. And it is double shear dito and sa likod, kabilang side. As you can see here, on the side view. Okay, so using the principle of simple stresses, the shearing stress is force over area. So you have P over 4, that means itong P natin is distributed to each of the bolts. So P over 4 yung makikerry niya na force. Then, divided by the bolt area, AB. So dapat di yan lumagpas sa allowable bolt shear stress. So, ito yung ating i-base sa number 31. Based on bolt shear. So, given yung P natin 320 kilonewtons, gawin natin siyang newtons, 320,000 newtons. Then, over 4, the bolt area, of course, the shearing area is circular. So, pi over 4 times the bolt diameter squared. It is multiplied by 2 because double shear tayo. Shall not exceed allowable 117 megapascal. Okay, by rearranging that one, if we cross multiply the dB, makukuha natin dB is greater or equal to 20.85. So, hindi pwedeng bumaba dito. So, we can call that one as the minimum required bolt diameter. Hindi pwedeng lumiit sa value na yan. So, based on the choices, ito critical talaga, no? Kailangan natin i-analyze. So, basta bolt diameter, we need to round up. Mas malaki yung diameter, mas malaki yung area resisting natin. So, mas magiging matibay. So, i-round up natin yan sa pinakamalapit na value. Okay? By investigation, 16 cannot be. 22 can be an answer. 25 can be an answer. 20 cannot be. Lumiit siya sa 20.85. So, yung pinakamaliit na pwede is yung 22 millimeters. So, use 22 millimeters in the choices. Okay? Next. Number 32. So, compute the maximum bolt hole diameter based on tension on plate. Based on tension on plate, P is 320 kilonewtons pa rin. Now, as you can see that yung allowable stresses in tension, dalawa yung binigay. Net area, meron siyang gross area. Now, if you want to involve the bolt hole diameter sa equation natin, we need to use the net area on plate. Alright? Kasi yung mangyayari dyan, yung magkakaroon ng failure is ito. Ito yung ating net area failure. By the way, we are designing here the main plate. Ito nasa gitna. Ito talaga yung basihan natin sa design. course, hindi naman natin to i-design na mag-fail yung splice natin. No? Ito talaga yung babasihan sa design. And upon checking also on these dimensions, as you can see that kung i-add natin yung dalawang thickness of these two plates, the splice plates, it will give us 24 millimeters. Mas malaki siya sa main plate. So, mas matibay talaga yung splice plates natin compared sa main plate. So, it is always designed here on the main plate. Okay? So, mangyayari dito yung failure will look like this. Kung sa side view, matatanggal yan. And kung 3D natin, so ganito siya. Ito yung net area natin minus the hole, minus the butas. The total dimension here, the total width is 50 plus 100 plus 50. You have here 200 millimeters. And ito naman are the bolt hole diameter. Tawagin natin siyang DH. Bolt hole. So that means, yung magre-resist sa force na yan, that is these areas only. The net area. Okay? So the same criteria. The tension on net area, FT, is force over this time the net area. Then shall not exceed the allowable net stress, which is 220 megapascal. Okay? Kunin lang muna natin si net area para hindi masyadong magulo sa calculation. By rearranging this one, we will have here net area must be greater or equal to P, which is 320,000. Cross multiply natin divided by the net area 220 megapascal. So makukuha natin dito, kung greater or equal yan, then we can call that one as the minimum net area required. 1454.55 square millimeters. Ito yung pinakamaliit na required. Hindi pwedeng lumiit pa dito. Okay? That means, yung actual net area natin, dapat mas malaki sa minimum net area. So what is our actual net area? That will be the net width. Okay? The net width is 200 minus dalawang bolt hole diameter. 200 by dalawang bolt hole diameter. Then multiply natin by the thickness. And of course, yung thickness natin is for the main plate. You have your times 20. So, naging net area niyan. Okay? Shall be greater or equal to the minimum required. 145.55. Alright, by rearranging this one, take note, naka-negative yan, naka-minus. Pag i-transpose natin yan on the other side, that will give us DH is less than or equal to 63.64 millimeters. Okay, mag-ingat tayo sa pagpili sa choice, no? Yung ibig sabihin dyan, DH is less than or equal. So, hindi pwedeng lumagpas dito. Dapat mas maliit siya sa 63.64. So, we can call that one as the maximum diameter of hole, a bolt hole diameter. Ito lang yung ina-allow natin, 63.64. Hindi pwedeng lumagpas dyan. Okay? So, based on the choices, 65 lumagpas na siya dito. So, that cannot be. 45 pwede. Mas maliit siya dyan. Okay? 60 pwede. Mas maliit siya sa 63. Also, 50 is pwede rin. Mas maliit siya sa 63. Pero yung pinakamalaking allowed, okay, for economical reason is 60 millimeters. So, gagamitin natin 60 millimeters na DH. Bakit nag-round down tayo, sir? I mean, nag-round up. Di ba nag-round down. Di ba magra-round up tayo basta dimension? Alright. So, makinig kayo dito. Although dimension yan, DH, pero yung effect niya sa area, effect niya sa net area natin, pag mas malaki yung hole diameter natin, mas liliit yung resisting area. No? That means, mas prefer natin, mas maliit lang yung butas. Para hindi lumiit yung resisting area natin. Iba kasi yung pag-diameter ng bolt. No? Kasi yung diameter ng bolt, pag malaki yung diameter ng bolt, mas malaki yung resisting area. Ba yung kanina? Okay? Or kung gusto mo talaga maging sigurado, then use the inequality sign. Alright, by the way, wala tong sa code kasi, allowable stress design, meron tong additional 1.67 sa 2001 NSCP, and meron siyang additional 2 mm sa 2010 15 NSCP. Pero hindi yun ginagamit dito, no? Talagang strength of materials na yung concept na ginagamit dito sa board exam. Unless pag meron siyang term, no, or bibigyan niya yung code na additional of that value. Okay? Now, number 33, compute the minimum bolt diameter based on bearing on plate. So, when P is 480 kilonewtons. Bearing on plates naman tayo. At titingnan na natin yung isang side. Titingnan natin dito, we have P. Each of these plates here, the splice plates will carry P over 2. Again, we are designing here the main plate. Okay? So, titingnan natin yan. Ito yung P natin. Each of these bolts will carry P over 4. So, meron niyang contact. Meron siyang contact kasi pag hinilan ito dito, magkakaroon niya ng contact dito. Dito pala. Meron niyang contact on this side. So, okay. Bolt diameter, yung magkakaroon ng contact is mismong bolt diameter, not the bolt hole. So, yung projected area natin, take note, it is a rectangle. Projected area. So, gagamitin natin dito is yung T1. T1 is 20. And ito siya is the bolt diameter. So dito yung ating forces. Each of these bolts will carry P over 4. Ma-divide yung P sa 4 na bolts. Okay? So force over area pa rin tayo. The bearing stress on plates and bolts is force. Yung force on each bolt is P over 4. Ito yan. Then, of course, yung ating bearing area for bolts and plates is diameter of bolts. Ito, diameter ng bolts times the thickness of the plate considered. Diameter, okay, that shall not exceed the allowable bearing stress. So, you have P 480,000 Newton this time. Alright, for area of the bearing area AP. The bearing area again is diameter bolt times the thickness 20 millimeters. Shall not exceed 338 megapascal. Rearranging that one, cross multiply natin siya sa kabila, makukuha natin bolt diameter must be greater or equal to 17.75 millimeters. So hindi pwedeng bumaba dito sa value na yan. We can call that one as minimum required bolt diameter. Again, dapat maingat sa pagpili. Ito yung pinakamaliit na pwede. So, 20 pwede. 16 hindi pwede, mas maliit sa dito. 22 pwede. Well, 25 mas lalong pwede. But yung pinakamaliit or minimum allowed is 20 on the choices. So, we will use 20 mm bolt diameter.